15. It picks up a lot on what we did with chapter 14, but we're going a little bit more in depth. So, quick review with our trigonometric functions and their ratios. Sine of an angle, we're looking at the y over the r, our opposite over our hypotenuse side. And then cosecant, which is reciprocal, r over y, hypotenuse over side. Cosine, adjacent over hypotenuse, x over r, secant as its reciprocal. Tangent, y over x, the opposite over the adjacent. And then cotangent, again, as its reciprocal. Okay? So, continuing with that value, now we're not looking at the same point every time. Because in chapter 14, most of our triangles were written in the coordinate grid. So we're looking in reference to the origin. But now we just have triangle, just chilling on their own in whatever orientation. And we need to be able to identify the ratios for whatever angle is requested. So if I want sine of A, what side is opposite of A? 7. 7 is opposite of A. What is the hypotenuse? 25. Now, how do I know, besides the fact that it's bigger, if I didn't have any numbers there, how would I know that that side specifically is the hypotenuse? Opposite the right angle. Okay? So you need to pay really close attention because as we move on, you won't have all three sides. So you need to be aware and cognizant that the hypotenuse is always opposite the right angle. All right? Now we've got sine of A. What's cosine of A? 24 over 25. The adjacent side over the hypotenuse side. And tangent. Yep. 7 over 24 is tangent of A. Okay? Easy enough. Opposite over hypotenuse, adjacent over hypotenuse, and then opposite side over adjacent. And all of this is in reference to angle A. Okay, we have to look at what angle it is our reference point. Opposite is 7, adjacent is 24, hypotenuse is 25. Now, let's flip it, and now let's find sine, cosine, and tangent of angle B. Okay, same ratios, but now we have a different reference point. So opposite and adjacent are going to change. So what's tangent of B going to be? 24 over 25.
Wait, I don't understand why. Wait.
Opposite of angle B is 24. Adjacent to angle B is 7. Okay? So opposite is 24. Hypotenuse is still 25. What's cosine of B? 7 over 25. The adjacent side over the hypotenuse. And then tangent. 24 over 7. Now what I want you to do is I want you to look at the three ratios we got for A and the three ratios we got for angle B. What do you notice about those? Explain.
Tan A.
Okay.
And then sin A and cos.
Okay. So sine of A is equivalent to cosine of B. What else?
Tan B is
Okay, so we've got the reciprocal, right? So tangent A is the reciprocal.
Cos A and sin.
Cosine A and sine B are equivalent. Okay? That's because sine and cosine are what we call co-functions. When I move from one angle to the other within a triangle, within the acute angles, I'm going to end up getting the same ratio. So we see that cosine of A and sine of B are equivalent. Sine of A, cosine of B are equivalent. And then tangent of A and tangent of B, they're not equivalent because they're not co-functions. But what do we think is the co-function for tangent? Okay, which is what? Which function? Cotangent. Tangent and cotangent are co-functions. Okay, so if I wanted cotangent, tangent of B is going to be equivalent to cotangent of A. And tangent of A is going to be equivalent to cotangent of B. And that leads us into our co-function formulas on the next slide. For any acute angle A in standard position, the cofunction, if we take the angle measurement, subtract it from 90, and then use our cofunction, it's going to be the same value, okay? So sine of A is equivalent to cosine of 90 degrees minus whatever that angle is, okay? Tangent, same with cotangent. Secant, the same with cosecant, okay? They're cofunctions. So if we take 90, subtract the angle value, we can use that new angle measurement in the cofunction, and we get an equivalent value. It's a little easier to see in practice. I have cosine of 52 degrees. The cofunction for cosine is sine, okay? That's why it's called cosine, because it's the cofunction, all right? I'm going to take the 90 degrees, I'm going to subtract the angle measurement. What do I have left? So cosine of 52 degrees is equivalent to sine of 38 degrees. You'll get the same exact value. Because we're using the cofunction. We're subtracting the angle measurement from 90 degrees to get the cofunction. So cosine of 52 and sine of 38 are going to be equivalent, just like cosine of A was equivalent to sine of B. Okay? If I took whatever angle A was and I subtracted it from 90, I'm going to get B. If I take whatever B is,
Subtract from 90 to A.
yep. And so we see those ratios, and then we can apply it to any angle, even if we don't have the triangle. Okay? So, tangent of 71 degrees, what's its cofunction? Cotangent. 90 minus 71. 19 degrees. So tangent of 71 degrees is equivalent to cotangent of 19 degrees. What's the cofunction for secant? Cosecant. Cosecant. Okay? So what am I going to subtract for cosecant? 90 minus 24, which gives me what? What'd you say? 66. Cosecant of 66 degrees is going to be equivalent to secant of 24 degrees. And we're going to see this kind of relationship come up later with some of our special right triangles as well. Speaking of special right triangles, we're going to start with an equilateral triangle. When I have an equilateral triangle, what does that mean? All sides are equal. Now, I'm going to take equilateral triangle, all sides are equal, and I'm just deciding that I'm going to use 2, 2, and 2 for all the sides. It can be whatever measure as long as they're the same, but 2 is kind of that baseline, and the reason we picked 2 is because when I cut it in half, and I look at half of this side, what's half of 2? 1. It's a nice easy number to divide in half, right? So I'm taking this triangle and I'm cutting it in half. I'm bisecting it down the middle. So this side instead of 2 becomes now a side of 1. If I cut a 60-degree angle in half, what am I left with? 30. So I'm forming a 30, 60, 90 right triangle. Okay? So I take an equilateral triangle, I cut it down the middle. Yeah, so now I get this becomes a 90 degree. So I keep this 60, this becomes a 90, and that becomes 30. Okay? And so you're going to see that the ratios on a 30, 60, 90 triangle end up being consistent over and over and over and over. What you're going to want to do as we go through this is you're going to want to practice and memorize how to create a special right triangle. We've got 2 because the ratios from those triangles show up so often that being able to create those triangles will allow you to find those ratios and those exact values without having to memorize them. Okay? Anyone that who took AAT, if you memorize the unit circle, you can do that instead, but the special right triangles are what derive that unit circle. So we're going to focus on the special right triangles. Okay? So we know 2 of the sides from the equilateral triangle. We started 2 and 1, and we just need to find this missing side. What can I use to find the missing side of any right triangle? Pythagorean theorem. So that's what we're going to do. We're going to use the Pythagorean theorem. A squared plus b squared equals c squared. Which one's a and which one's b doesn't matter. We just have to make sure that c is the correct value. Okay? So which side is going to be c? 2. Okay? I'm going to solve for x. 2 is my longest side. That's my hypotenuse. So 1 squared plus x squared equals 2 squared. So we solve. What does x equal? Square root of 3. Okay? So x is the square root of 3. Every single 30, 60, 90 triangle is proportional to that ratio. Legs 1, root 3, and the hypotenuse 2. And so when we take any 30, 60, 90 triangle and we make it bigger, okay, I can have side lengths of whatever that are proportional to that. Whenever we write our ratios, they'll always simplify down to the same exact values. We always simplify our fractions. And since it's proportional, they will always simplify down to the same few values. And we'll see those over and over and over. They're very, very redundant. So now that we have our 30, 60, 90 triangle, we can find the trigonometric ratios for each of those. So for sine of 60 degrees, what two sides am I going to use? Opposite and hypotenuse. Okay, what side is opposite of my 60 degrees? Square root of 3. So root 3 over what? Over 2. Okay? Yeah.
If this root number...
We're going to rationalize, and we'll get there in a moment. Okay? Cosine of 60 degrees.
I just had
Tangent. Because it's root 3 over 1, right? Root 3 over 1, which is just root 3. Okay? I'm going to write the root 3 over 1 so that when we get to cotangent, what's cotangent going to be? Not the opposite. Reciprocal. 1 over root 3. Now again, I don't want a radical in the denominator, so I need to rationalize. How do I rationalize it again? Yep. Multiply by a radical. So I'm left with root 3 over 3. So cotangent is now root 3 over 3. Okay? Secant is the reciprocal of which function? Cosine. So if cosine is 1/2, secant is what? 2.
Wait, so square root of 3 times square root of 3?
Yeah, because square root of 3 times square root of 3 is the square root of 9. The square root of 9 is 3. What was the secant is 2, because the reciprocal of 1/2 is 2. Cosecant is the reciprocal of which function? Sine. So cosecant of 60 degrees is going to be 2 root 3. Rationalize it. Yep. 2 root 3 over 3. No, you need to memorize how to make the triangle so that you can come up with these whenever you have this triangle. Whenever you have a 30, 60, 90. Or you can memorize them. But there's a lot of numbers to memorize. So the triangle is going to be a lot more helpful. And the more you use it, the easier it'll be to remember. So that we can derive it on our own and then fill in the values and then we've got it for whatever we need. Now, because we know cofunction identities, since I know sine of 60 degrees, what's the cofunction for sine? The cofunction for sine. Cosine, right? So if I know sine of 60 degrees, I also know cosine of what angle? 30, right? 90 minus 60. I know cosine of 30. What's cosine of 30 then? If these are cofunctions, what's cosine of 30? Go back to this. That's cosine of 60. What's cosine of 30? Root 3 over 2. They're co-functions. So 90 minus 60. If we go back to the triangle, we can see it. Okay,
So
cosine.
now we're looking for sin 30.
Yeah, but that 30's right there. So
Mhm.
that's the change over the hypotenuse.
Over the hypotenuse. Remember we had these equivalency with these ratios here? It's the same idea, just with a different triangle. If I know sine of 60, I know its cofunction is cosine of 30, and I know they have to be the same. If I have cosine of 60, I also have sine of 30 is also 1/2. Cotangent of 30 is also root 3. Tangent of 30 is root 3 over 3. Cosecant of 30 is 2. And secant of 30 is 2 root 3 over 3. The importance in recognizing that cofunction, it saves you a whole lot of extra work. If you recognize that the redundancy and the repetition that's within a lot of these ratios. If you want to sit there and try and calculate all 6 of those for each angle, you're going to spend a lot of time doing that. But if you can remember those co-function identities and that equivalency, it saves you a significant amount of time. You don't have to do any extra work. All you really need to do is look at your triangle to calculate these 3. Once you have those 3, you can get the other 9.
Is the CSE 30?
Yeah, all those ones in green are 30.
So when you get when you subtract the numbers, it's always the same as the
your own house.
first number.
It's always going to be, so when I subtract this, that's always from here because I'm taking 90 minus 60.
That's cosine.
Yep, and that's going to give me the 30 and it's always going to end up being the other angle because triangles add up to 180. Well, that's 90, so it leaves me 90 left. So these two have to add up to 90 as well. So they're always going to be the difference of 90. Alright? Now we have another special right triangle. It's our 45, 45, 90. Okay? We have an isosceles triangle. What is an isosceles triangle?
2 of the sides of the same.
2 of the sides are the same. Which means that 2 of my angles are also the same, which is why they're both 45, 45. Okay? So my 2 acute angles are 45, 45. Now, I've got 2 sides given that are congruent. I'm using 1 because 1's easy. You could do 2, you could do 3, you could do whatever. Okay? Because the ratios are still going to be the same. Okay? But I'm using 1, and then my Pythagorean theorem, and let's go ahead and find the hypotenuse, the measure of the last side. Okay? Pythagorean theorem. So every 45, 45, 90 triangle is going to have that same ratio. And we're going to see a lot of redundancy, just like we did on the 30, 60, 90, with any right triangles that have the 45 degree angles in them. Okay, we're going to see a lot of redundancy. Actually, we're going to see a little bit more than did on the last one, because I have less numbers to work with. On the first one, I had 1, and I had 2, and square root of 3. Here, I've got 1 and the square root of 2. Those are the only 2 numbers I can make. Not a lot of different fractions that we can make with just those 2 numbers. So, sine of 45. As if I want the cofunction. I want the ratio right now. Okay. Opposite over hypotenuse. Rationalize it.
Opposite of what?
Opposite of 45 degrees. Okay. Cosine of 45 degrees. Right? Because the opposite side and the adjacent side are both the same. So sine and cosine are both going to be root 2 over 2. What about tangent? 1. Opposite over adjacent. 1 over 1. Cotangent. 1 again. So we see that sine and cosine are equivalent. We see that tangent and cotangent are going to be equivalent. Any guesses on secant and cosecant?
They're gonna be equivalent.
They will.
No, they're gonna be reciprocal.
They're going to be equivalent. Secant of 45. Square root of 2. And cosecant. Same thing.
Wait. So how is it 2? If he said the SEC and the cosine are the same.
I said secant and cosecant are going to be the same. Secant and cosine are reciprocals.
That's what I said.
I was asking about secant and cosecant.
Oh.
Guys, sine and cosine are equivalent. Tangent and cotangent are equivalent. Secant and cosecant are going to be equivalent.
How does it equal 2 though? Because if it's reciprocal, it would be 2 over square root of 2.
So if you go back to that, because you can't have a square root of 2 in the denominator, so we rationalize it, but if we go straight back to here, the reciprocal is just root 2 over 1, and then we don't need to rationalize it. If you did the reciprocal of this, which you can, once you rationalize it, you get 2 root 2 over 2, which then just simplifies back to root 2. Okay? So it's always best to go back to the original before you rationalize to get your reciprocal. So we've got our 30, 60, 90 and our 45, 45, 90 right triangles. Okay? And so we saw a lot of repetition. These were all the numbers. Okay? For every single 30, 60, 90 right triangle or 45, 45 right triangle, you're going to get these values. 30, 60 are linked together because they're in the same triangle, and then 45 is a triangle all on its own. So we've got a 45, 45, 90, and then we've got a 30, 60, 90. It's going to be a little skinnier. Okay? I don't expect you to memorize all these values. Now, if you memorize the unit circle because you missed class, you've got these values memorized. But those things, those higher level skills, derive from these special right triangles. So what I do expect from you is to know how to construct those on your own, which is why I went through those basic triangles so that you can then find any of these values. And we'll actually be taking other triangles and figuring out if they match with the special angle. Okay? So going back to our special right triangle, remember that we start with an equilateral that we cut in half that has sides 2, 2, and 2. So when we take those sides, it turns into a 1, 2, and then we can solve for that middle side or that last side that was formed by that bisection. Or you can memorize it as 1, 2, and root 3. Okay, just make sure your hypotenuse is the biggest side, which is 2. And so once you have that, then you can find any of your trig ratios for 30 degrees or 60 degrees. When you've got a 45, 45, you're looking at a triangle with 2 equal sides of a ratio 1. Okay? Doesn't have to be 1. You could do 2. You could do 5. You could make this any number that you want. Your radius will change to match, or your hypotenuse will change to match with those new sides. But when you form the fractions, they will always reduce down to these values every single time. They will always reduce down to these values. And so you'll see that repetition over and over and over. And a lot of times when we're dealing with these trigonometric functions, most of the time we want exact values. If you plug cosine of 45 degrees into your calculator, you're not going to get an exact value. It's going to round it to a decimal. And then you're like, what do I round it? You don't. I want an exact value, which is root 2 over 2. Get that from your calculator alone. You have to use your ratios in order to get those. So I want to make that abundantly clear now. You can't fully rely on your calculator. Now, when we go into some more application problems and we're finding angle measurements, then yes, we're going to be using our calculator a little more, which means you're going to need a calculator that can do trigonometric functions. If you don't have a calculator that can do sine, cosine, tangent, or the inverse, then you're going to be up the creek a little bit. So you need to make sure that for some of our later stuff, you have a calculator that can do that. Final caveat, no Casio calculators, period. Okay? If that's what you have on test day, then you don't get to use it. Okay? I have my reasons. It is what it is. So you can use Texas Instrument. You're supposed to be using the TI-4, but as long as it's a basic scientific calculator that can do trig functions, I'm not going to be too picky at this point. But, okay? It's a brand. It does that. And I don't want it to do that. I want you to do it. Okay? All right? Any other questions, comments, concerns?
So it's all this.
Are you free 6
Various
period?
conundrums.
No, not today.
So it's all
Come back
this.
tomorrow.
Yeah.
I'm fast food.
It's wrong, but okay.
Is the best one.